Hello, everyone. So Paolo is from Thales, and he's been working for quite some years now on developing a roll-to-roll fabrication process, I believe using an aerospray for graphene-based supercapacitors. And I think the technology has now reached a level of maturity where it is being transferred to the industry and commercialized. So he's going to tell us more about the process, the technology, and the future of this work. So what will happen now is I will make myself disappear, but I will be here to change the slides. So, Paolo, over to you.
Okay, thank you very much for the nice presentation. So, thank you very much again for inviting me. So, I would like to talk about our technique, our spray gun deposition technique of carbon nanomaterial, actually, that we have implemented to fabricate supercaps. So, next slide, please. So very briefly, I will introduce the concept of supercap. In this case, supercap are composed by two collectors that you can see here in black, and inside you have an electrode and an electrolyte. So when you apply a bias, so you move the charge between the two collectors, and you can store the charge in an electrostatic way. So you have no chemical reaction inside this kind of device, but only non-Faradic reaction. So thanks to that, this kind of device are not be considered as batteries, considering that in batteries you have a lot of chemical, you have a chemical reaction in order to store more energy, but are mainly based on non-Faradic reaction. Next slide, please. So the main advantage of this kind of device is that we can have I could say a number nearly infinite of cycles, considering that we have no chemical reaction, so we have no exchange of metal. We have a good reversibility, and the main drawback is that you can't store a lot of energy as in case of batteries, but we have mainly the energy that we can store is about 3-5 watt-hour per kilogram, compared to 30 by 40 watt-hour by kilogram. So next slide. So we can say that next slide, please. So you can say so in another there's not a problem. So we can say that actually that if in case of battery you have like in case of supercap we have a sprinter, so we have to deliver energy very quickly. In case of batteries we have a marathonian that have to deliver energy, small energy for a lot of time. So this is very different. These are two very different devices. The main application for supercaps you can see here are applications where you need to deliver energy very quickly and not to store a lot of energy. So you can see the Kappa bus in Shanghai, so where the bus is completely driven by supercaps. After that, you have the mobile phone fast chargers where you can charge your phone in 5 minutes. We have also the emergency exit of 380, where if you need to go out of the aeroplane, if you have any problem, actually, you need to open very quickly the door, and so you need a peak of energy in order to deliver the people inside. And so after that, you have a normal application like a standard application like aerial lift, forklift truck, which is a quite common application. Also rocket ignition, and also you have, for example, a tramway in Heathrow, for example. Next slide, please. So up to now, the supercap were made using what we call activated carbon. Activated carbon is a powder of carbon that the main advantage is you have a large surface. So if you have a large surface, you can store more charges. And so for this reason, they have been used up to now, and also because they are really not expensive. However, the main issue about this kind of material is that only the 2/3 of the pore of the surface is not used, considering that the pore size are not sufficient to use all the surface of this powder to store the charges. Next slide, please. Here you can see a scheme. For example, you can see that the charges, when you apply a bias, move to the collector. Next slide. So you can see the charges in red that are moving to the collector. Next. And so you can see, next slide. And so you can see that when they arrive to the collector, the problem is that you can all the charges, because the problem is that the pore size, the distribution of the pore size of the electron is not adapted to store all the charges, and the dimension is not, it doesn't fit the